10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
MDS to,
We have ignition, we have a liftoff.
Roll program is in on time. Vehicle response is normal.
After years of meeting, designing and testing, on the 5th of September 1977, NASA launched a project that turned out to be one of their most successful projects ever, the Voyager 1.
Very smooth flight, very small attitude disturbances.
In the summer of 1965, NASA made calculations that would reveal the possibility for a spacecraft to launch in the late 70s to visit all 4 outer giant planets, using the gravity of each planet to swing itself towards the next planet. Such an alignment of the planets was a once-in-a-lifetime chance, as it only occurs every 176 years. The initial plans for the Mariner Jupiter Saturn 1977, which was the initial name for the Voyager 1, was to only fly to Jupiter and Saturn and build upon the heritage of the earlier Mariner spacecraft that flew by Venus, Mars and Mercury. The launch of the Voyager 1 was not the first launch of the Voyager-project, as Voyager 2 was launched earlier on the 20th of August in the same year. Even though it launched earlier, Voyager 2 was expected to reach Jupiter and Saturn after Voyager 1, as the latter was following a shorter trajectory. Each Voyager space probe carries a gold-plated audio-visual disc, containing images and sounds from Earth, in case one of the Voyager probes will ever be found by intelligent life forms from other planetary systems. On the 5th of March 1979, Voyager 1 made its closest approach to Jupiter. This resulted in some very interesting pictures, videos and discoveries. Highlights of the encounter include the discoveries of active volcanoes on the moon Io, which was a bit of a surprise. It was the first time active volcanoes had been seen on another body in the solar system. Eruptions are so common and so large that the entire surface can be buried under 100 meters of material every 1 million years. Another discovery was the Jovian ring system, which was created from micrometeor impacts on the planet's inner moons that hurled dust particles into orbit and stayed there. This created a ring primarily made out of dust. Though the ring system is not as easy to see as the rings of Saturn. Furthermore, Voyager 1 also discovered 2 other moons, Phoebe and Metis. Next to that, the Great Red Spot was discovered to be a huge cyclone-like storm that has existed for at least 357 years, producing wind speeds up to 432 kilometers per hour. After some successful gravitational assist trajectories at Jupiter, Voyager 1 eventually visited Saturn and its system's moons and rings, and had its closest encounter with Saturn on the 12th of November 1980. Winds blow at high speeds in Saturn. Near the equator, the Voyagers measured winds of about 500 meters per second. The encounter again resulted in some interesting pictures and videos, along with some other discoveries. One of its discoveries was the fact that about 7% of the volume of Saturn's upper atmosphere is helium, while almost all the rest is hydrogen. The lower abundance of helium in the upper atmosphere may imply that the heavier helium may be slowly sinking through Saturn's hydrogen. The discovery of the moons Prometheus and Pandora around the F-ring of Saturn led to the confirmation of the theory that these are necessary for the ring system, as it keeps the ring material in line. Besides the discoveries on Saturn, the mission's intention was also to get a better look at Titan, Saturn's largest moon and the second biggest moon in the solar system. The data gathered by Voyager 1 show a thick Earth-like atmosphere, the first nitrogen-rich atmosphere found beyond our own planet. It also suggested the possibility of seas of liquid methane and ethane on the surface of Titan. After the encounters with Jupiter and Saturn, Voyager 1 proceeded its journey towards interstellar space, an exciting journey for mankind. Before leaving our solar system forever, on the 14th of February 1990, Voyager 1 took the chance to take some last photographs, which is known as the Solar System Family Portrait. This is the only series of images that captures Venus, Earth, Jupiter, Saturn, Uranus and Neptune arrayed by the Sun. After the series of images was transmitted from Voyager 1, engineers of NASA decided to turn off the camera in order to save energy for other important aspects of the space probe, such as the collection of data on the solar wind and interstellar space. Unfortunately, this meant that the engineers would never collect new images from Voyager 1. Voyager 1 continued its way towards interstellar space, and on the 17th of February 1998, it passed the distance of the Pioneer 10 and became the farthest human-made object from Earth in space. Followed by this event, the space probe crossed the termination shock on the 16th of December 2004, which is the boundary marking one of the outer limits of the Sun's influence. The termination shock also marks the inner boundary of the Helios heath, which is a sort of bubble formed by solar wind. After crossing the termination shock, the solar wind abruptly slows down and heats up as it is encountered with interstellar winds. The journey continued, and finally, on the 25th of August, Voyager 1 crossed the heliopause, which is the boundary between the Helios heath and interstellar space. It marked the first human-made object in interstellar space. The crossing itself, however, was not confirmed until the 9th of April 2013, as it took some time for the data to reach Earth. While Voyager 1 continues its journey in interstellar space, it has enough electrical power and thruster fuel to keep going until 2025, which on the scale of the project is a short period from the current day. By the time we cannot hear from Voyager 1 anymore, the space probe is at a distance of 22.1 billion kilometers from the Sun. Eventually, Voyager 1 will reach other stars and is destined to wander the universe forever.